We are looking at this question, which is the inverse. This symbol is inverse Laplace of this fraction. Okay, so actually we've dealt with inverse Laplace on this channel. I think we have over 40 clips, 40 videos on Laplace transform. So this is just additional. This is just a question, and I want to see the solution to that. Observation 1. This one should be 7x squared. Sorry for that. 7x squared. Inverse Laplace of 7x squared minus 41x plus 84 over x minus 1 times x squared minus 4x plus 13. So observation 1, the degree of numerator is 2. And that of denominator is 3. Okay, that's observation 1. Then observation 2 is that the denominator has been segmented into 2 parts, whereby you have the first one as a linear part and we have the second one as a quadratic part. Okay, then the third observation is that this quadratic, is it factorizable or not? Let's check it. The factors of 13 is 13 and 1, and it can't give us minus 4x. It cannot. Okay, so in that case now, this is what? This is not factorizable. It is unfactorizable. So what next to do now? The next thing we are going to do is to use partial fraction. Okay, use partial fraction. So we're going to have now this fraction will be equal to, this fraction will be equal to a linear part, that will be a over x minus 1. Then the quadratic part, which is unfactorizable, that will be, since the first constant is a, then the next one will be x plus c all over x squared minus 4x plus 13. So we have the constant where a, b, and c are the constant we are going to find. Okay, so the next thing, multiply through by the common factor. Multiply through by x minus 1 into bracket x squared minus 4x plus 13. Multiply through by that. So if you do that, we're going to have 7x squared minus 41x. This one times the common factor. So we have a times this denominator we cancel. Then we have a times x squared minus 4x plus 13. Okay, then followed by this fraction also times the common factor, and that will be equal to plus what? Plus bx plus c times x minus 1. Okay, so what we are going to do now, we want to find a way of cancelling some certain expression. Okay, so we can get the one of the constants. So let's let x be equal to 1. If x is 1, this whole expression here, we cancel 1 minus 1. So that's 0 times this one. So that one gone. Just have we want to get our a here. Okay, so substitute. Then we have 7 minus 41 plus 84 equal to a into bracket 1 minus 4 plus 13. So if you do this one, that will be 50 equal to 4 minus 4, that's minus 3 plus 13, that's a 10a. So in that case now, a is what? A is 5. A is 5. Okay, we've gotten a now. Let's look at the way we can get the other constants, the b and the c. So what we can do is to equate coefficients. That's what we're going to do. That's the next thing. Okay, because we can't substitute anymore for this kind of questions. Okay, so equate the coefficients. So let's do that. Before we equate coefficients, let's do the arrangements of the coefficients. Plus 84 equal to, here you have a times this, that's a squared. I can take s squared. Then here bx times x, that's plus b. So I'm through with the coefficient of s squared. Then the other one, let's go for the coefficient of x. This will be a times this one, that's a plus minus 4a, minus 4a. Okay, minus 4a. Then here, bx times minus 1, that's minus what? Minus b. So the x is already outside. Okay, and then this one times this one, that's what? Plus 3. And then for the constants, we have 13a plus 13a, followed by another constant we have, that'll be what? That's minus c. Okay, so that's what we have. So equate the coefficients, equate coefficients. So for the s squared, if you equate that, the coefficient of s squared is 7 on the left hand side, equal to, on the right hand side is a plus b. And our a is what? Our a is 5. Okay, then b is what? B is 2. And finally, let's equate the constant terms and get the equate the constant terms. Equate the constant terms. So that will be equal to 84 equal to. We can use either this one or this one to get the. Yeah, we can use either of these two expressions. Yeah, we can use the coefficient of x. We can use the constant terms. So equate the constant terms. We have 84 equal to 13a minus c. Okay, and that will be 84 equal to 13 times 5 minus c. And that will be 84 minus 65 equal to minus c. And that will be 19 equal to minus c. So c is equal to what? Minus 19. So that's what we have. Then the next thing to do, we can now go back here. That inverse of the question, 7x minus 41x plus 84 all over x minus 1 s squared minus 4x plus 13 equal to, my a is what? Inverse of a is what? 5 over x minus 1, then plus b is 2x minus 19 all over s squared minus 4x plus 13. Okay, so that's what we have. This quadratic expression minus s squared minus 4x plus 13. We can turn it to perfect square, which will become, take one of this, then the sign you have here, minus, half of 4 is 2, then close it, square, then minus here, what you have added here, that's this 2, take it out, and square that, plus what? Plus 19. That's that on perfect square, and that will give x minus 2 squared plus what? Plus 9. Okay. Then we now have inverse Laplace 5 over x minus 1 plus 2x minus 19 all over x minus 2 all square plus 9. Okay, so what we're going to do now, this x here, we're going to make it of this form, x minus 2 squared. So how do you do that? Let u be equal to what? X minus 2. Okay, and that will be u plus 2 equal to x. Okay, so then you can have now 2x minus 19 will become 2 times u plus what? U plus 2 plus 19. And that will be equal to what? 2u minus 19. This is minus 19. 2u, 2 times u, that's 2u plus 4 minus 19. And that will be equal to what? 2u minus 15. Laplace of 5 over x minus 1, then plus 2u minus 15, that's u squared plus 9. Okay, so let's return the u back to the original expression, so which will become inverse of 5 over x minus 1 plus 2 into bracket x minus 2 minus 15 all over x minus 2 squared plus 9. So we return everything back to normal. Okay, and then we've succeeded to make the expression here and here to be the same thing. Then inverse of sum of functions will be inverse of each of those, inverse Laplace of sum of functions will be inverse of each of those functions. Okay, then plus inverse Laplace of 2 into bracket x minus 2 all over x minus 2 squared plus 9, then plus minus inverse Laplace minus inverse Laplace 15 over x minus 2 into bracket what? Into bracket x minus 2 squared plus what? Plus 9. Okay, so that's all we have. Then we can take this 5 outside the inverse. That 1 over what? X minus 1. Then plus this one also, these two can go outside of the inverse. That will be what? X minus 2 over what? X minus 2 squared plus what? The 9 is what? 3 squared. So then the last one, minus what? Minus inverse. 15 can come outside. 15 can come outside. Minus 15. 1 over x minus 2 squared. Okay, plus 9. Okay, minus 15. So then the next thing to do, I'll just take us back to memory lane. That's inverse Laplace of exponential is equal to what? 1 over what? X minus what? The attachment to that t. Okay, so and if you take the inverse of both sides, inverse Laplace of both sides, okay, inverse of a Laplace function will give you what? Laplace function. That's equal to what? Inverse of what? 1 over what? 1 over x minus a. So this is clear. Another one we need to note, another table we need to note is inverse of x minus a over x minus a all square plus b square. Okay, this will be equal to what? Exponential, what you have here, at, and then once this and this is the same, that will be cos what? Cos what you have here, bt. Okay, another one is inverse of b over x minus a all square, then plus b square. So what you have here, you must have one of it at the numerator, and that will give us what? Exponential to the power of what you have here, at, sine what? Sine b of one of what you have here, b what? bt. So that's that. We can quickly apply that. So I've taken us back to memory lane. Okay, taking us to table. So, and I will go to put the descriptions of some of those things, the link to 1 or 2 videos on this aspect, so that you can see more in-depth explanations and more examples on these segments. 5 inverse Laplace of 1 over x minus 1, then followed by 2 plus 2 inverse Laplace of x minus 2 over x minus 2 all square plus 3 square, then minus 15 inverse Laplace. I'm going to do a little adjustment here. What I have here is 9, and for the standard table we expect one of these to be here. This is 3 square. 9 is 3 square, so we expect one of that to be here. So I'm going to do that. That will be 3 all over x minus 2 all squared plus what? Plus 3 squared. Okay, so in order not to alter the equation, what I brought in here, I need to cancel that value outside the inverse Laplace. Okay, so whatever you injected here, you have to cancel it outside. Okay, so on the final note, you now have 5. The inverse of this is what? Et. All you have here is 1t. So 1 times t is t. And then on this one, this will be plus what? Plus 2. E 2t. Check the table. Yeah, check here. E 8t. My a is what? My a here is what? Is 2. Okay. Then minus 15 over 3. That's 5. And that will be equal to what? Sine what? No, 5. Exponential to power 2t. And then cos 3t. Then minus 5 exponential 2t for the last one here, for this one. Okay, 15 over 3, that's minus 5. Then this one is what? Exponential. My a is at 2 here, so that's 2t. And then sine, whatever you have here, one of it, 3t. So that finished that question. Okay, so if you're new on this channel, please subscribe right now and click on notification bell so that you can keep track of the updates of this channel. And also please invite your friends and family to do likewise. Thank you.